Hi guys, so we are going to start learning about probability. So first let's look at some notation. This P here is just stating probability. A is just whatever event we're talking about at the time. So to find probability, it's a fraction, number between 0 and 1. 0 meaning it's not possible, 1 meaning 100% sure it's going to happen. But we use fractions most often, but we could use decimals and we could use percents. But the way we find it is whatever we're looking for, the number of favorable outcomes. So if I'm looking for heads, it's the number of heads. If I'm looking for a even number on a die, that's the number that we could get there over the total number of outcomes that are happening. So I just mentioned we can have decimals, we can have percents, we can have a fraction, but that's what we're looking at there. All right, so let's get into it. Different things that you've definitely seen before when it comes to probability. And so we're looking at coins, dice, cards, spinners, pulling a marble out of a sack, and we want to see which game would you want to play based on probability of winning. So how to win if you flip a coin and land on heads? Well, there's one possibility of getting heads out of 2 total possibilities. Rolling a 6-sided die and landing on a 1, there's 1, 1, 6 options. Drawing an ace in a standard deck of cards. Now there are 4 aces and there are 52 cards in a standard deck of cards. Spinning the spinner and landing on an odd number. On this spinner, there are 3 odd numbers out of 5 total. And then pulling a solid black marble out of the bag without looking, there are 2 black marbles and 5 total possibilities. So trying to figure out which one we would want to do in order to win, you're going to want to change those to decimals or percents just so that we can compare them a little bit better. So 1/2, we know that's 50%. 1/6, I'll help you out, is 17%. 4 out of 52 is 8%. 3/5 is 60%, and 2/5 is 40%. So which game would we want to play? Well, this one, it's got our greatest probability of winning. Little bit of vocabulary here. Complementary events. So complementary are 2 events that cannot happen at the same time. And so if you have one, the complement is not that one. That's what it is. So if the probability of landing on an odd number is 60%, then the complement is the probability of landing on an even number, which would be 100% minus 60%, or 1 minus 3/5, which gives us 40%. So complement is the probability of it not happening. And we take 1 and we subtract the probability of it is happening. So probability of a randomly selected student in a school being left-handed is 0.28. What is the probability of selecting one who is not left-handed? Well, that's our 1 minus our 0.28, and we end up with 0.72. Standard deck of playing cards is used. What is the probability of not drawing a heart? All right, so there are 13 of each in a playing deck, so 13 hearts. If we want not a heart, we want 1 minus our 13 out of 52, which is ends up being 3/4 once you simplify it. The nice thing with probability is that you don't actually always have to simplify it, so you could have left it the way it was, but if you just typed it in your calculator, it will spit back out 3/4 for you. All right, there's a couple different types of probability that we talk about. Theoretical probability is what should happen. All right, so what should happen? So what should happen is every time I flip a coin, all right, if I flip it 50 times, there should be 25 heads and 25 tails. But that's not necessarily what does happen. So that's what experimental probability is what did happen. So the difference here, number of favorable outcomes over total number of outcomes for theoretical, and number of times it actually happened over the number of times that you tried it. So examples here, theoretical, if tossing a coin, probability of landing on a heads is 1/2, 1 out of 2. Coin was tossed 100 times, heads appeared 60 times, therefore we would expect the probability of the coin landing on heads on the next toss is, and so then we would have 60 out of 100. All right, so we know that 1/2 is 50%, this is 60%. So theoretically, ideally, it should be 50%. However, when we did the experiment, it was actually 60%. So kind of looking at that with an example here, a group of students conducted an experiment by rolling a 6-sided die 50 times and recording their results in the table below. What is the experimental probability of rolling a 3? So there were 12 threes, all right, and it said that we did this 50 times, so 50 is our denominator here. An even number, so we've got 2, 4, and 6, so we add those up, 6 plus 10 plus 7, 6 plus 10 plus 7, that gives us 23 out of 50. Then a number greater than 4, so that's our 7 plus 7, we've got 5 and 6 that are greater than 4, and so that gives us 14 out of 50. Number that is not a 1 or 2, so we're adding up everything after that, 12 plus 10 plus 7 plus 7, and we end up with 36 out of 50. And then how does the experimental probability of rolling a 6 compared to the theoretical? So experimental is what actually happened, so that was 7 out of 50 compared to the theoretical probability. Well, there's 6 numbers on the die, and there's only 1 6, so 1 out of 6. So we would need to make those into decimals so we could compare them better. This is 0.14, and this is 0.17. So we would say that the experimental probability is less than the theoretical probability in this case. All right, looking at a couple more examples here. Spinner is divided into 5 equal sections labeled A, B, C, D, and E. What is the probability that the spinner lands on A or B? Well, A or B, there's 2 of those options out of 5 options total. Number is randomly selected from 1 to 20. What is the probability that the number is a multiple of 3? Well, multiples of 3, 3, 6, 9, 12, 15, 18. The next one's 21, which is bigger than 20, so it's not that one. So there are 6 possibilities out of 20 here. I'm not going to keep going with some of these because I feel like it's pretty self-explanatory from there. So we're going to move on to the next rule of probability that we have, and that is called the addition rule of probability. So addition is actually the probability that one event or another event occurs. All right, so if I want to know what the probability of getting a red or a blue is, I need to add those 2 probabilities together. What's the probability of getting a red? What's the probability of getting a blue? We have another vocabulary term here, mutually exclusive events. Mutually exclusive means they can't possibly happen at the same time. All right, so I can't roll both a 3 and a 5 at the same time, so those are totally mutually exclusive. All right, so if they are mutually exclusive, the probability of one or the other is the probability of one plus the other. So that's only if they're mutually exclusive. There's another rule we'll look at if they're not mutually exclusive. So we'll look at the non-mutually exclusive events next because that's actually what happens most often. All right, events are non-mutually exclusive if they both happen at the same time, possibly. For example, if you draw a card from a deck, you could draw a card that is both a heart and a queen of hearts. So when that happens, we end up with some overlap. So we have to see how we deal with that. So if we look at this chart over here, so to the right, is a chart of classes that students are taking in their junior year. How many students are taking Algebra 2? Well, we just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 are taking Algebra 2. How many are taking AP Stats? 1, 2, 3, 4, 5, 6. How many students are taking both Algebra 2 and AP Stats? 1, 2, 3, 4. All right. How many students are taking either Algebra 2 or AP Stats? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So then the next question is, why can't we add the number of students taking Algebra 2 to the number of students taking AP Stats to get the number of students in Algebra 2 or AP Stats? Why can't we do that? Well, the answer is some are taking both and would be counted twice. And then what would we have to do to this sum to get the correct value? We would have to subtract the number that are in both, because we don't want to double count them. So if we subtract them once, then they're counted once, but not double counted. So that's when things are not mutually exclusive. That's what we have to do there. All right, so let's look at some more examples here. So this is a formula here that you're going to want. It is, lucky for you, they now are on the back of your booklet, which is very nice, except they have some notation here that might look a little different than what you see. So on the back of your booklet, you can mark it up for now if you want to, but you obviously can't use the markup version on a test or on the Regents. All right, but this little U right here means or, and this little upside down U means and. All right, so this is the formula we're talking about right now. If I want to find the probability of A or B, I take the probability of A plus the probability of B and minus the overlap, which is the and, the ones that are both A and B. All right, so kind of looking at what that looks like, we could use a Venn diagram. You've used those in the past. That might help you see it a little bit better. Overlapping area represents the elements shared between the two. Non-overlapping is that's unique to each one, and then the area outside the Venn diagram, the circles here, show what numbers don't belong in either spot there. All right, so it might help you to see kind of what's going on here. So if we're looking at this, we talked about from the previous page that there were 4 students that are taking them both. So maybe that's the easiest place to start. 4 students that are taking them both. We know there are 11 that are taking Algebra 2. Well, there's 4 already accounted for here, so that means there's 7 only taking Algebra 2. There were 6 people taking AP Stats, so 4 of them are already accounted for here, so 2 of them are only taking AP Stats. And then we had some that weren't taking anything. So student number 13 here is empty, student number 10 here is empty. So we have 2 of them that are outside the circles but still inside the diagram there that weren't taking either one. So again, some vocabulary, some notation, that's what's important. Again, you don't have to focus on the formulas, those are given to you, but understanding the notation is important. So intersection is this symbol right here. It means and or both. Union means one or the other. All right, you're combining both the A's and the B's, and it's a U shape. All right, but it means or. It might not seem like it for union, but it does mean or. And then complement, it can either have a little apostrophe there or it can have a little C there. It means just not what we were talking about. So for this one, not A is everything that's shaded in here. A is the only thing that we're not including in this one. All right, because we want everything that's not A. All right, let's start applying this formula a little bit here. So, in a survey of people who recently bought a smartphone, 50% said they were looking for long battery life, 35% said they were looking for high quality camera, and 65% said they wanted a long battery life or a high quality camera. If a survey respondent is selected at random, what is the probability that the respondent wanted both a long battery life and a high quality camera? So it's asking for us to find the and. So if I'm finding the and, all right, I'm using this up here, this probability formula. We don't really need to worry about the n so much. It's the p one, probability formula. I'm looking for the and. So when I go to write stuff down, that's going to be what I call my x there. So I need or equals a plus b minus, and this is what we don't know, x. So if I look for the or was up here. So 65%. Now we don't use percents as percents. We need them as decimals. So 0.65 equals, we need 1 plus the other. So long battery life was 50 plus high quality camera was 0.35. And we're looking for the and. So I'm going to call that x. So again, I'm using this formula right up here. It is on the back of your booklet. All right, but when you're looking for or and, that is the formula you're going to want to use. So now we just solve for x. All right, so I can combine these two here. So I get 0.85 minus x, subtract my 0.85. I get negative 0.2 equals negative x, divide by negative 1, divide by negative 1. And so I get 0.2 equals the probability of, let's see, battery and camera. There we go. So probability of battery and camera. All right, let's look at another one. At Central High School, students are only allowed to enroll in the school's advanced science program if they have already taken either AP Biology or AP Chemistry. Out of 750 incoming seniors, 200 took AP Biology, 150 took AP Chemistry, and 50 took both. Given this information, determine the probability that a randomly selected incoming senior is allowed to enroll in the advanced science program. All right, so we want to know if they can enroll in this program, and they said the stipulations are they have to either AP Bio or AP Chemistry, so or. So we're looking for the or this time. So that's going to be my x equals, and then I have 1 plus the other. All right, so we have out of 750, 200 took AP Bio, so 200 out of 750. Plus my 150 who took AP Chemistry out of 750, minus my 50 who took both. So 1 plus the other minus both. All right, and let's see. If I just type that into my calculator, I'm going to end up with 2/5. Now, unless they tell you differently, you are welcome to leave it as a fraction, unless it tells you decimal form, percent form, or if you're doing something that it's asking you to round. All right, when a book is selected at random from a library, it is probability that its fiction is 0.60. The probability that it is both fiction and a bestseller is 0.25, and the probability that it is neither fiction nor a bestseller is 0.20. All right, calculate the probability that a randomly selected book is a bestseller. All right, so we've got, let's kind of write down the information that we've got. So probability that it's fiction is 0.60. Probability that it's fiction and bestseller is 0.25. I'm looking for probability that it's a bestseller. And so the one that I'm missing is probability that it's fiction or a bestseller. Well, I know the probability that it's neither. So that's actually the complement of one or the other. So if neither is 0.2, then our or one or the other is 0.8. So I was just listing out the information I had, knowing the piece of the formula that I'm missing and trying to figure out how I can get that missing piece. So now I can set up the formula. The formula says the OR equals 1.60, the probability of fiction, plus the probability of the other, which I don't know is X, minus the probability of the overlap, which was 0.25. All right, so if I combine these here, I end up with 0.35. Then if I subtract, I get X equals 0.45. All right, one more on this page. Study of streaming services found that 48% of people who use streaming platforms regularly use Netflix. All right, so might as well maybe just write down as we go this time. 62% use Hulu. And 85% use either Netflix or Hulu. So probability of Netflix or Hulu equals 0.85. Find the probability that a selected streaming platform user is a Netflix user who uses Hulu. So I'm looking for Netflix and Hulu. So again, if I look at that formula at the top or look at it on my formula sheet there, the formula says the OR, which is 0.85, equals one of them plus the other one by itself minus the overlap, which in this case is X. So then I combine my like terms, and I get 0.1 minus X sorry, not 0.1, 1.1, my bad. I knew something was up. 1.1, and I get 0.25 minus, divide by a -1, I get X equals 0.25. So again, that was a 1.1. Sorry about that. All right. Last one. At a local gym, 45% of the members attend yoga classes. So probability of yoga equals 0.45. 35% of the members use the weightlifting area. And 30% of the members do not attend yoga or use the weightlifting area. This is a do not. So the ones that do use one or the other is the opposite of 30%, which would be 70%. So probability of yoga or weightlifting equals 0.70. So find the probability that a randomly selected gym member participates in at least one of these activities. That's the OR. At least, that's the OR. All right, which we already found. 1 minus our 0.30, which was neither, gives us the 0.70. And then find the probability that a randomly selected gym member participates in both activities. So that's where we need that formula. We have the OR equals 1 plus the other minus the both, which we don't have. All right, so let's see if we can add these together correctly this time. And when I do that, I get 0.8. Subtract the 0.8. I get -0.1 equals -X. Divide by -1. Divide by -1. X equals 0.1. All right, go ahead to Delta and try those problems that I left for you. If you need any help, definitely feel free to reach out. And we will start next class by practicing some of the stuff that we're learning right now.